book number 56. Or, quote unquote, if something says it varies directly. As a little side note, if there's direct variation, there's probably, is it inverse? I believe it's called inverse, or indirect. There is such a thing as inverse variation. And what the difference between them is, when you think of direct variation simply means as one goes up, the other one goes up. And it is a proportional thing. Can I do that? Proportionately. Let's go south here. An example of that is something that varies directly, I suppose, the time you travel and the distance you go. If you're driving in a car at 60 miles an hour, the time you travel, as you travel a longer time, you go a farther distance. Okay, they both go up. Whereas inverse variation is the opposite of that, where as one gets bigger, the other one gets smaller. And an example of that would be the farther you travel, the fewer gallons, the fewer gallons of gas you have. That would be inversely variation, because as one goes up, the farther you go, the smaller you get. But we're not looking at that one today. I just wanted you to see it there. Now there is a little formula, just like with the y equals mx plus b thing for linear equations. When you talk about direct variation, this is your little formula that the book throws at you. Y equals k times x. Y equals k times x. Where the letter k, children, is what's called your constant of variation. It's really very similar to a linear equation, really, in the grand scheme of things. Here is an example of it. Domino's or whoever has, you can, hot and ready pizzas for $5, right? Little Caesars. Hot and ready pizzas for Little Caesars is $5. In that varies directly with how many pizzas you buy. Okay? Your constant of variation is 5, because that's how much the pizza costs. X is the number of pizzas you buy, and Y is how much cash it's going to cost you. Okay? So let's say you buy 0 pizzas, you pay $0. You buy 3 pizzas, you're going to pay $15. You buy 6 pizzas, you're going to pay $30. It is proportional, and it varies directly. The other thing, Lucas Spaniel, before I lose you completely here, never, when you talk about direct variation, can you have a plus or minus like a linear equation. Okay? You can't have +3 because direct variation has to start at the origin if you're graphing it. Okay? It's like proportion. When we talk about something being proportional, it has to, when one is 0, the other one has to be 0. Okay? For something to be direct variation and to be proportional, it's going to be start at that origin there. But this is really what you want to kind of figure out there. Let me write that down. Y equals k times x. When you see that all put together, in your mind you should think direct variation. Now, using the skills of mathematics, Jack, you got all that stuff done before, or are you with me? Would you say you got 80%, 90%, all of it?
95. Maybe 85.
Right. Okay. I can change my stuff around. How many different equations could I make with this that would be the same, just moving letters around? I could, Lauren. Yeah, solve for k. And if I solve for k, what does k equal? Well, you just divide by x. So k equals y divided by x. So if you ever wanted to find your constant of variation, you just take your y number divided by your x number, and that'll tell you what your letter k is. And you could also solve this for k, or for x, I'm sorry. If I solved it for x, what does x equal? Jack?
X equals Y divided by K.
Y divided by k. Okay. But usually this is the form that we pretty much always kind of go with. Okay? That's the one that we go with. Let me see if I can find something that they actually asked me. So, here's what they do. They throw this at you, something like this. Y plus 8x equals 0. Y plus 8x equals 0. Is this direct variation? And the question you have to ask yourself is, can you get it to look like this form right here? Can you change things around so that it looks like this? Nick?
No,
Why not?
there's a K.
Well, but this is, the number in front of the x is always the k. Just like in slope-intercept form, the number in front of x is that letter m, which is slope. Okay? The k can be any number.
Yes, you could.
So what could you do to this? You could subtract your 8x to the other side. Y equals negative 8x. The plus 0 doesn't matter. And if I asked you what the constant of variation is, you would tell me, Nathaniel, it is? It's the number in front of the x. Yeah, k equals negative 8. So yes, this would be direct variation. If you graph this, you'll get a straight line starting at 0 or going through 0 that goes up the graph. What about this one? Y over 10. Y over 10 equals x. Is that an example of direct variation, yes or no? Can I get it to look like this? Where y equals k times some number? By doing what, Emma Kreis? Multiplying both sides by 10. Because the 10s would cross off, you'd be left with y equals 10 times x. What is the constant of variation? Jack?
10.
10, the number in front of the x. How about this one? X times y equals 6. Can you solve that so that it looks like y equals some constant times x? Well, if I'm solving it for y, what do I do, Crenshaw Hammer? Nope. If I'm solving this for y, what do I have to do? Divide by x. So I want the y by itself. So now I have this. Y equals 6 over x. Is it direct variation? No, it is not. Okay? Because the x has to be times the constant of variation, not divided by the constant of one and the other. So this would not be direct variation. If you graphed that, let's do that and see why it wouldn't be direct variation. If I graph this, let me make a table just to see what happens here. And I pick my y values, or my x values, and you give me your y values. Pick something that works out. Wait a minute. Stop just a minute. What's the easiest number to pick? 0. And what happens when you put a 0 for x? 0. You can't do it. So that right there is one of the reasons why it's impossible, because you can never divide by 0. So this is not even really possible. There's no other point you could put for it over there. If you put 2 in for x, y would be 3. If you put 3 in for x, y would be 2. If you put 6 in for x, y would be 1. What would happen if you graph this? 1, 2, comma 3. 2, 3, comma 2. 6, comma 1. And I can get a line like this. Now, why would that not be direct variation? Because as the x values get bigger, the y values get smaller. And direct variation says that as x get bigger, y has to get bigger. Really, you have to think about this. In direct variation, you always have to have a positive slope. Slope has to go up that way. What else are you asking me? Oh, here, how about this? Write these numbers down. This is exciting, isn't it? 2, -14. 5, -35. And -321. If I asked you if this is direct variation, yes or no?
Yes.
Yes.
Oh, we've got two different camps. So Jeremy Schwartz, you haven't really, throwing us your input for the day. Is direct variation yes or no? Here's the question you ask yourself. Do you multiply x by the same number every time to get y? Because if you do, then it's going to be direct variation. Because that is your constant of variation. In other words, this. To go from x to y, because I know y equals k times x, to go from x to y, what do I multiply by? Do I multiply this by -7? Do I multiply this by -7? So my constant of variation is -7, and this is directly proportional. Because it's the same, stays the same. If this would have been a 20, then no, it would not be. But since it's all the same thing, it is. Oh, the excitement. Hold on a second, let's see what else we have. Ooh, how about this one? 3y equals x. Direct variation or not? Tell me why. Jeremy, huh? I can't have x divided by 3? Think outside the box here just a little bit. Yeah, Jeremy says, well, you divide by 3, you divide by 3. But notice how before that other one had the x on the bottom? X can be on the top because this is really the same thing as this. X over 3 is really the same thing as saying 1/3 times x. Okay? So your constant of variation actually in this case is a positive 1/3, and that is direct variation. You can have an x on the top and a number on the bottom because you can always make that a fraction. You could have y equals 2x over 3 simply because that's the same as y equals 2/3 x. As long as the x is on the top, you're good. X can't be on the bottom, but it can be on the top. And I think life is good for all involved.